Moving on with adding feature by feature to our native Aloha scheme, now that we know that slotted Aloha is better than pure Aloha, and slotted Aloha still couldn't get rid of collisions, we need to understand how can we incorporate some additional functionality that helps us to prevent collisions, and if collisions happen, detect collisions. In this module, we shall start with one of the bases of modern day Ethernet technology called carrier sense multiple access with collision detection. In this module, we shall understand what is the basic idea and how is it related to human analogy. Then we'd look at the CSMACD states and how CSMACD incorporates binary or exponential back-off algorithm. An interesting reference titled Computer Networks by Andrew S. Tenenbaum by Pearson Education gives interesting comparison of CSMACD with the predecessors and how is it related to the Ethernet technology. Professor Tenenbaum is the same author who writes in operating systems, in computer architecture and networks. Imagine a nice, polite conversationalist who wants to initiate a discourse in a very polite and decent manner. The first thing that he would always consider would be that if someone else is speaking, he ought not to speak. And if somebody interferes in the middle of his conversation, he stops out of courtesy. That is what governs CSMACD as the underlying idea. CSMACD incorporates carrier sensing, that is, listening to the channel for the presence of any voltages, referring to the activity by other nodes. And if the channel is idle, the channel is occupied by the node because no one else is using it. And if it is busy, then the communication has to be deferred. If two people, aka two nodes, simultaneously listen to the channel, find it idle, and transmit at the same time, collision is bound to happen. This coincidental transmission is very much possible because two persons who sense the channel find it idle and start to transmit. If that happens, then collision has to be detected. The collision has to be detected because continuing with the transmission that is bound to fail because collision has already taken place and the packet is now corrupted, there is no point. So the collision has the collided packet has to stop. If it is not stopped, number one, it is a pointless exercise. Number two, the bandwidth is unduly wasted. CSMACD in the activity plane can be seen to demonstrate three states. The first one is contention. When multiple nodes compete, collisions happen. So nobody is making any effective use of the channel. So the nodes back off and attempt to transmit at a later stage. When one of them gets the chance, starts to transmit, occupies the channel. After that, there may be an interval when nodes are either not active because they do not have data to be sent, or the nodes have deferred their communication because they have just sensed too much collisions. Binary exponential back-off algorithm is an intelligent mechanism that lets nodes back off when they sense a channel as idle or if collisions happen in a very intelligent way, such that they should not back off for an indefinite long period, or they should not back off short enough so that when they reattempt again, the transmissions would again suffer from collision. The principle of binary exponential back-off algorithm is that the collisions are counted by every node. and it is represented by M. For example, if it is the first collision, the value of M is equal to 1. So it is binary exponential algorithm. So 2 to the power M minus 1 would actually give 1. So either 0 or 1 would be the total members in the set K. Now the LAN card is going to wait for 512 bits worth of time for a 10 megabits per second channel and multiply it with K. So if K is randomly chosen between 0 and 1, because that's available in the set for the first collision, if K is equal to 1, then 512 bits worth of period shall be waited for before the node attempts to retransmit. If the value of K is 0, then the node would wait for 0 time interval and would attempt a retransmission in the next time slot. If collision happens once more, the value of M is now going to be 2, and 2 to the power 2 minus 1 is actually equal to 3. So the total set members would be 0, 1, 2, and 3. In this case, the node would have 4 options to choose from. It can wait for 0 time slot or no time slot. It can wait for 1 time slot, 2, or 3 time slots. Depending upon which value it randomly chooses, it may suffer a collision or may have a success. This continues till the value of M reaches 16. That value of 16 implies that the network is heavily loaded and some other mechanism has to be incorporated.